Okay, we are going to go ahead and continue with what will be the final session for the Honors Pre-Calculus B Semester Exam Review. And we are on number 74. And for this one, I'm actually going to use a double angle formula, which is the following. And so just like in 73, I'm going to set each equation equal to each other, substituting this guy with this double angle identity. I'll move everything to one side because then you'll be able to see that I can factor to solve the rest of the equation. So factor out sine. Set each part equal to 0. So this one will end up getting cosine of theta equals 1/2. So there are two angles, and they also specify that they want theta to be between 0 and 2 pi, not including 2 pi. So there are two angles between the 0 and 2 pi where sine of those angles are 0, and that is 0 and pi. And I'll call these theta 3 and theta 4. There are two angles that give me cosine of theta is 1/2. They're in quadrant 1, which is pi over 3, and in quadrant 4, pi over 3. Okay, so we'll write my final answers up here. So I'm actually going to have 4 answers. Okay, and now just like the previous problem, to find all the r values, because these are polar coordinates, I would plug each of these into one of these, and I'm going to use the first one. So I'm just evaluating each angle at sine, with sine. So sine of 0 is 0, sine of pi is 0, sine of pi over 3 is square root of 3 over 2, sine of 5 pi over 3 is negative square root of 3 over 2. So that is the set of answers for 74. So let's continue with 75. So we are going to now do a bunch of problems related to sequences and series. So this is an infinite series, and it's geometric if you look at it, because you are multiplying by 2. So we say my common ratio is 2, I'm multiplying by 2. Let's just make a note that this is infinite. In other words, it keeps going forever. And they want me to use sigma notation. In other words, summation notation. I'm going to have my index starting at 1 and going to infinity because it's an infinite series. And if you don't recall, to find the nth term of a geometric sequence, this is the formula. And that's exactly the formula I'm going to use here. So A1 is 8, R is 2, I'm multiplying by 2 every time, to the n minus 1. Okay, and if you write all this out, you should get all of these numbers here. Okay, so that is correct. Let's continue with 76. So this is an arithmetic series, and it's finite. So if you don't recall, for arithmetic, this is the nth, how to find the nth term, where my common difference d here, in this case, is 4. So this is arithmetic, because I'm adding 4. So if I plug this in, I have A1 is 11 plus n minus 1 times 4. And I'm going from, I'll start at 1. And you actually don't have to start at 1, but your equation will change if you don't. And I have 1, 2, 3, 4, 5, 6, 7 terms. So I'm going to stop at 7. And if you'd like, you can kind of rewrite this and condense it to 4n plus 7, which I believe is the answer they give in the answer key. Okay, so there's 76. continue with 77. So 77 asks to determine the sum of any for the infinite series. They give us this series here. There's actually a slight typo. There should be this 1 here in between 3 and 1/3, but it's not. So make sure you put that in. So this is, if you look at it, an infinite geometric series, because I'm multiplying by 1/3, so r is 1/3. So if I have a geometric series, it's infinite, and the absolute value of r, which is still 1/3, is less than 1. Okay, so if I have these two things and absolute value is less than 1, that means that the series, what we call, converges. In other words, there is a sum. And the formula for that sum, for the infinite sum, is a1 over 1 minus r, where r is your common ratio. So in this case, absolute value of r is 1/3, which is still less than 1. So there is an infinite sum, and they ask us to determine that sum. So I do a1 over 1 minus 1/3. So I get 13.5 is the sum of this infinite geometric series. Okay, let's continue with 78. So 78 says the infinite sum or series, starting at 1, going to infinity, 3 times 2 to the n. Okay. So this is geometric, and you can tell because you have this multiplication here and you're raising a number to something that's changing. So this is actually my r value. So r equals 2, and 2 is positive, so you don't have to worry about taking the absolute value, but 2 is greater than 1, so we would say this geometric series diverges, which means there is no sum. Okay, or at least no finite sum for an infinite series. Okay, let's move on to 79. 79, kind of a similar idea here. N equals 1 to infinity, 8. This time we have 3/4, so this is still geometric. And if you're paying attention, you should already know the answer, in the sense that r is less than 1, or absolute value, but again, you don't need the absolute value because 3/4 is already positive. So this does converge. Okay, so I'm going to use the infinite sum formula for geometric series. Again, there is no infinite sum for arithmetic series, because you would just keep adding bigger and bigger and bigger numbers. So I have a1. Now a1, if I plug in 1 here, I have 3/4 to the first, which is 3/4. 3/4 times 8 is 6. So my first number, a1, is actually 6, not 8. Okay, so be careful with that. Over 1 minus r. So the sum is 24. Okay, so that is number 79. Let's continue with 80. So almost there. So they say for 80 and 81, evaluate starting at the index of 1, going to 4, 3n plus 1. So all this means is you're going to write out what this notation, what it actually means, and what the sum actually is. So I'm going to say, start with n being 1, plus n being 2, plus n being 3, plus n being 4. Okay, this will give me 4 plus 7 plus 10, so I'm adding 3 every time. It's 13, which if you add all those up, you get 34 as your answer. Okay, so there's number 80. Let's look at 81. Same idea, different formula. So going from 5 to 10. and 4n along the way. So this is 4 times 5 plus 4 times 6 plus 4 times 7 plus 4 times 8 plus 4 times 9 plus 4 times 10. So if I do this, I get 20 plus 24 plus 28 plus 32 plus 36 plus 40, which added all up gives me 180. So there's your answer for 81. Okay, let's look at 82. 82 actually has a typo in the answer key based on the question they've given. So they give you that absolute value of x is greater than 1. And this is actually going to be my r value, because if you look at the series, you're multiplying by x every time, right? So r is x. But if r is x, right, if r is x, I can replace this with r, meaning absolute value of r is greater than 1. So this would diverge. Okay, because r is greater than 1. So you're just adding bigger and bigger numbers to this geometric series, okay? So there actually is no sum, okay? The answer key says that the answer, I believe, is 1 over 1 minus x, okay? That would be true if this was less than 1, okay? So keep that in mind. Okay, but given what they actually wrote, the answer should be there is no sum. Okay, let's look at 83. So we're going to start to use the binomial theorem, but I'm actually going to use Pascal's triangle. So if you don't remember Pascal's triangle, that is this pattern here. And I'll review how I got this real quick if you can't already see it. There's the 1 here on the edge. So to get this number, I add these two. To get this number, I add these two. To get this number, I add these two. And I just keep going, okay? And all the sides are 1s. So if I'm looking at to the 4th, I need the 5th row. So this is the row that I'm looking at. And those are actually my coefficients without doing any other work. So those are kind of like my basic coefficients. I'm going to write this as follows, because the Pascal's triangle, the pattern for this only works if you have a plus here, so I'll just write it as plus negative. And so I start with x to the 4th, and I go down all the way to x to the 0, which is here, but x to the 0 is 1. So I started with this number, and I went decreasing in powers. Now I start with -2, and I go increasing powers. So I have -2 to the 0, -2 to the 1st, -2 to the 2nd, -2 to the 3rd, -2 to the 4th, okay? So all of this becomes, if you evaluate the first one, you get x to the 4th, because -2 to the 0 is 1, 1 times 1 is 1, okay? Here I have -2 to the 1st, which is -2, times 4 is -8, so I'm left with actually minus 8x cubed. The next one, -2 quantity squared is 4. 4 times 6 is 24. Next one, I'll get -8 times 4 is -32. And then finally, 16. That's my last one, okay? Please note that there is also a typo in the answer key for this. This says 64 in the answer key, but 16 is correct. That should be your last number, okay? All right, so there's 83. Let's go on to 84. So another expansion problem. And this time we're raising to the 5th. So I need the 6th row. One, two, three, four, five, six. Yep. Okay. So now I'm only interested in the coefficient of x cubed. So if you look here, this is going to be x to the 5th coefficient disregarding the 2, but I'll take care of that in a second. So I have x to the 5th, x to the 4th, x to the 3rd. So this is the guy I'm interested in. So you can write it all out, or you can do 10. So just looking at this guy here, maybe I'll highlight that. This is the one I'm kind of interested in here, because that's going to be part of the x cubed term, which is what I'm interested in. Okay, so I have 10 x cubed, and if you kind of think about it, if this is x cubed, the 2 powers I'm going the other way, so this would be 2 to the 0, 2 to the 1st, 2 to the 2nd. So I'm also going to have a 2 to the 2nd here. Okay, so if you put this all together, you get 2 squared is 4, 4 times 10 is 40, so 40x cubed. So the answer is 40. Okay, so you can save some time there. If that doesn't quite make sense, you can write out all of this just like we did in the previous problem, and then look at the x cubed term. Okay, and you'll see that you'll get 40. Okay, so let's continue to 85. So all of these are good things to practice just to save some time on the test, since there is a time limit. Okay, this one I'm also going to use Pascal's triangle. Again, you can be using the binomial theorem, the one that involves combinations, to do this as well. I just prefer Pascal's triangle. And I need the 5th one, so I can actually stop there. 1, 2, 3, 4, 5. Okay. So I am interested in the coefficient of x to the 9th y, the coefficient of that. So that one's not quite as obvious, so I actually am going to write all of them out. So I start with x cubed to the 4th. So notice how I took this guy and put it to the 4th. So I'm kind of like substituting it in. X cubed to the 3rd, x cubed squared, cubed to the 0, which will just give me 1. Then I do the same thing, but I go the other way with 5y to the 0, 5y to the 1st, 5y squared, 5y cubed, 5y to the 4th. Okay? And if you look at this, you actually only care about the one that has an x to the 9th, which will be this guy right here. Okay? Because if you look at it, this one will give you 4x to the 9th, power to a power you multiply, 5y, which will give you 20x to the 9th y. So the answer is 20. Okay, so that one, again, you can save some time. You don't have to write out all of it as far as evaluating all of these, because you only really care about this one. So the answer is 20 for 85. Okay. And finally, number 86, the final problem of the packet. And it is also one of the easiest questions in the packet, because all you have to do is use a given formula that they gave you. So if you look at the very front, it says the distance from a point x1, y1 to the line ax plus by plus c equals 0, which is exactly the form I have, is the following. The absolute value, don't need to draw them that big, okay, because don't think I need that much room, but if I look at this, I have absolute value of ax1 plus b y1 plus c, okay, all over the square root of a squared plus b squared. Okay, and the bottom will always be positive because it's the square root. So here, I'm just going to list out what I have. x1 is 2, y1 is -3. Okay, so in other words, this guy goes here. This is the y1. A is 3, B is -4, and C is 12. So A is here, B is here, C is here. You're just matching it up with this formula. And so all you have to do is plug in everything. So you have A times x1 plus B times y1 plus C, all divided by the square root of A squared plus B squared, okay, which gets you to absolute value of 30 over the square root of 25. So we can drop the square roots because 30 is already positive, and 30 divided by 5 is 6. Okay, so the distance from the point 2, -3 to this line is 6 units. Okay, and that concludes the Honors Pre-Calculus B Semester Exam Review for 2015-16. I appreciate you guys watching. Again, always feel free to go back and watch the other videos. Otherwise, good luck on the test, and again, thanks for watching. Bye-bye.